Hey everyone, it's Actuary Dude over here with another question. So, the force of interest delta t is a function of time, and at any time, measured in years, is given by the formula, all of that. Derive and simplify as far as possible expressions for Vt, where Vt is the present value of a unit sum of money due at time t. Okay, so let's look at part I. All it wants us to do is really find V of t, which we've really been doing in all of the other questions, so it shouldn't be too difficult. Now, in order to find V of t, we need to find e to the negative integral of delta t. Now in this case, we'll take the first bit and we'll put it between 0 and t over there, and we've got our function of 0.03 plus 0.01 t, we can say dt. Now the integral of all of this is 0.03 t plus 0.0, I'm just going to say 0.5 because that's divided by 2 t squared, and that's in between t and 0, and there's a negative out the front, and that's e to the power of all of that. So what's the next bit that we've got? Well, we just need to sub in t into here, so when we do that, all the t's will remain the same, and then we're going to minus when we sub in 0 into there, and we sub in 0, that'll all become 0. So there's really just that negative out the front, which will then be, in fact I'll write it in here, e to the negative 0.03t minus 0.005 t squared, and that is for when 0 is less than, not that it really matters too much, but less than or equal to t, which is less than or equal to 8. Okay, and so that's what we've got. Now, in order to find v of t when t is greater than 8, well, first we've got to find out what v of 8 is equal to. That's an 8 there. So v of 8, all I'm going to do is just excel in this case to try to solve that, because we're just subbing in 8 into t. So it's going to be e to the negative 0.03 times 8 minus, that's going to be 0.005 t squared, which is 64, which is that, so it's negative 0.56. So equals negative 0.56. Okay, that's v of 8, and now we can just find e to the negative integral between time 8 and t. So e to the negative integral between t and 8 of our new delta t, which is 0.05 dt. And so in order to find that, well, the integral of that is just 0.05 t, so e to the negative 0.05 t in between time t and time 8. And so what's that going to become? Well, when we sub in t, it's going to be itself, so e to the negative 0.05 t, and it's going to be minus negative 0.05 times 8, which is then plus 0.4. And if we multiply this whole thing by v of 8, which is e to the negative 0.56, it should give us our v of t for when t is greater than 8. So this is just going to be equal to, well, in fact I can write it in here, e to the negative 0.05 t, and then that's negative 0.56 plus 0.4, which is then going to be minus 0.16 for when t is greater than 8, or the way the question did it was 8 is less than t. Doesn't really matter too much. Okay, so that's part I. That's pretty good. Now calculate the present value of £500 due at the end of 15 years. So that's A. So in order to find the present value where we've got, it's not a continuous payment, but we actually had £500 paying at the end, well that's just 500 times V of 15 years. And we know that in this case t is measured in years. So okay, all we have to do is sub 15 into our function over here. So I'll go back to Excel and just get rid of this bit and say we've got the exponential of negative 0.05 times 15 minus 0.16, and that equals that bit over there. And if we, sorry, I just want to make sure that I've done that right, equals negative 0.05 times 15 minus 0.16. Okay, so then that should be pretty good. Equals 500 times that amount, we get 201.26 pounds. So we need 201.26 pounds in order to get 500 pounds in 15 years' time. Alright, and now let's look at part B. It says calculate the rate of discount, so that's interesting, per annum convertible quarterly, so that's d to the 4 implied by the transaction in A. So really, I mean, I'm just going to write this out differently because I don't really remember coming across a question like this. If we started with £201.26, then we multiply that by 1 plus our quarterly interest rate, so that would be like that, divided by 4, that's our effective quarterly interest rate, divided by 4, annual, sorry. So this is the nominal annual rate convertible every quarter, so when we divide it by 4, it's going to be the effective quarterly rate, and then we'll multiply it by 4 periods, or 4 periods times however many years we want, in this case it would be 15 years, should give us £500. How do we find it the other way with the rate of discount? Well, we're going to start off with £500, and then we're going to multiply it by 1 minus d to the 4 divided by 4, and that's the effective quarterly rate. So this whole thing is the annual rate that we may need to find. Sorry, this is the effective one, so just this bit over here will be the annual one, to the power of 4 times 15, again, which will give us 201.26. So now if we go back to Excel and just solve for D4, well, all we're going to do is just say we have 201.26 divided by 500, and then we can put that to the power of 1 over 60 to get rid of that to the power of 60, which is that bit over there. 1 minus this answer to get rid of the 1 minus on the other side. Sorry, equals 1 minus that answer. And then we'll just multiply it by 4 because we're dividing by 4. So that's 0.060209. So d to the 4 is equal to 0.0602. Yeah, I think that was it, 0.060209. So I can just say a 1 over there, which is then going to be equal to 6.02% per annum convertible every quarter. So that's what we've found, and now we can find part 3. A continuous payment stream is received at that, so that's row of t, units per annum between time t equals 12 and t equals 14. Calculate the present value of the payment stream. So let's remember that, 10e to the negative 0.02t. So I'll just solve that over here. So that was between 14 and 10, and this is what the present value is going to be equal to. So that was that was 10e to the negative 0.02t. I think that was right. And then we're going to have to multiply it by our v of t, and v of t when it's greater than, or it's between 10 and 14, well, that was just e to the negative 0.05t minus 0.16. I believe that's what it was. And we can say dt. Now we can simplify all of this. We can actually take out our 10. We can say it's still between 14 and 10, and then say e, so negative 0.02t minus 0.05t, that's going to be minus 0.07t minus 0.16 dt, and then the integral of all of this is the same function divided by the derivative of this top bit, so that's going to be 10, and that'll be e, same function, 0.07t minus 0.16, and then I can divide everything by negative 0.07. So I'm going to do it like that, and then I'll just take that out and put it in between 14 and 10. So now all I have to do is sub in 14 and 10. So it'll be this multiplied by when we sub 14 in here, minus when we sub in 10. So what does that give us? Let's just use Excel to solve this bit. So I'm going to say over here, we have our first bit equals 10 divided by negative 0.07. And then we are going to multiply that by, I'm not sure where I can move this, but I'll just see how we go. It's the, I'll put in brackets, the exponential of negative 0.07 times 14 minus 0.16. That's going to be minus the exponential of, and I'll just move it along here, exact same thing, negative 0.07 times 10 minus 0.16, and close brackets, and all of that is equal to 14.76329. So 14.76 is what we got. 14.76. So that looks pretty good, and that should be the right answer. So thank you very much for watching.